right, folks, it's my favorite time of the day because it's experts on data time. Very excited because today we're going to be talking about DNA and Swordfish. And you're probably saying to yourself, wait a second, those sound like entirely unrelated to storage topics. But in fact, both are very, very related to not only current storage, but the future of storage. So I'm super excited. We've talked a little bit about this subject in the past, so this is a great chance to kind of refresh, see where we're at. And I've got two amazing folks. So before we get started, I'll ask, of course, my name is Eric Wright. I'm the host of the SNIA Experts on Data podcast, also the co-founder of GTM Delta, and a very proud SNIA community member. And I've also got with me today, I've got Richelle. So Richelle, if you want to give yourself a quick introduction.
Sure. Thanks, Eric. Richelle Ahlvers. I have been the chair and primary author for the Swordfish specification for almost 10 years now. And so we're really excited as we move this spec forward. How do we bring in new features and functionality? And that's really what we'll be talking about here today.
Excellent. And Vincent's joining us as well. So folks that are brand new to you, Vincent, let's give an introduction.
Sure. Thank you, Eric. So I'm Vincent Franceschini. I'm the co-chair of the DNA Data Storage Alliance, community of SNIA, and definitely happy and very thrilled to be connected with this discussion, because for us, Swordfish is a very good example of the kind of things that the DNA data storage community need to embrace, in order to prepare for the future use of our technology in data centers.
And there's certainly been the pace of innovation that we're seeing in the great wide world that's going on right now is almost tough to watch. As we say, the folks that have got red eyes from keeping up with the situation, there's a lot going on. But what I always love to tell people is the reminder that what we're doing today is made possible because of very solid foundations that we know we can depend on, which is why being in the SNIA community has been such an incredible part of my own career, and just leaning on the folks that are telling these stories and they're building and innovating together from a standards, first approach, as well as a collaborative approach. This is one of the rare spots where we see potentially competitive, company brands that all come together because we all see the opportunity to move the world forward in a positive way that we can, measurably add value to, what enterprise and even consumer technology is able to do. So Richelle, given that this is your area of coverage and Swordfish has been in your backyard for quite a while, let's talk about your view on why this is an important both topic and time.
Okay, great. So I'm going to follow up on one thing you just said, which is, building on solid foundations, but also being able to move quickly. So this is something that folks don't necessarily think of from a standards organization, but Swordfish, we build on top of the MTF's Redfish, so we focus exclusively on the storage applications. Both Redfish and Swordfish release updates up to 4 times a year. And so we can react very quickly to new features and functionality. So that's kind of one of the, how is this relevant? The other piece is we're focusing on manageability here. And one of the things that is really key about standards-based management is it allows the companies working in these spaces to just, to focus on where their actual value add is instead of treating their entire management stack as value add. If you can just level out the parts that everybody's doing, and then it gives you more time and more ability to focus and deliver value add functionality. So that's really what we're trying to do here as we expand into DNA, right? So the DNA Data Storage Alliance has been a part of SNIA for a couple, 3 years now. We know it's taking some time. This is really cool technology, which we're not going to get into that much today other than to talk about the manageability aspects of it. But if you do have a chance, go watch some of the materials on it. It's fascinating. But because this is going to take a while, we can increment our way there as well with, what would a basic model look like? What are the standard components that the DNA Data Storage Alliance is driving in all of these different kinds of devices and across multiple companies. And then I'm coming in with this viewpoint of how can I make that match the models we already have and just do as incremental as possible. And so that's kind of where we are. I'll let Vincent in a minute talk about what the components are we're talking about here, but what we've done so far, and we have out on the SNIA website currently for public review a draft that highlights what these objects would look like and how we would model a device. What we're really looking for now, though, is a lot of feedback from other folks, either working on something else or working in the DNA communities as well, saying, hey, this doesn't quite match what we want to do. How can we change that? We're very early in the cycle right now. We're looking at modeling for various components, getting the naming to me of components is trivial. I want to make sure we've got the right components in there. And then, saying, do we have enough for people to get started? And then we can add more as we go. Again, we can turn these specs out up to 4 times a year. We could have something ready to go before SDC this year, depending on how much input we get back. If we're getting input more slowly, it'll take a little bit longer. But we do expect to try and roll this out and roll out the models here as quickly as we can. So with that, I'll ask Vincent to talk about what's going on in the DNA Data Storage Alliance side of this work.
Thank you, Richelle. So let me just say that the work we started to do with the Swordfish, technical work group, is really a way to inspire the DNA data storage community to embrace all the topics related to manageability. Why is that? So with DNA data storage, besides being a very exciting topic, as Richelle just mentioned, there's so much stuff going on in that community, on the scientific front, the technology front. So I invite everyone interested to take a look at our pages on the SNIA website. But beside that, there is a tremendous new ecosystem of technology and equipment that is about to be combined together to enter in the data center. Unlike, for example, just to give you some different perspective, unlike other storage technology, where you basically provide a recipient and you pull data into it, with DNA, you build the recipient and the data at the same time. It's a completely different perspective as to what you need to consider moving forward. And obviously, everything, all these resources need to be harnessed in a defined, in a standardized environment, and that's where all the discussions around manageability makes a lot of sense. But another key point, it's about data. It's about writing data. It's about reading data, from this new medium. So with DNA data storage technologies, the write path and the read path, include completely different set of technologies. On one hand, you synthesize DNA. On the other hand, you sequence DNA. Different types of equipment, that would need to be combined in order to provide an automated way to access data, like with any other storage media. So all these equipments and all the stages that it takes to go from the original digital file, in order to make it on the DNA, medium, and then back to a digital format. All those steps need to be well understood, well mapped into a process that can then be monitored in a standardized fashion. The same way the resources that will be involved need to be identified and monitored in a standardized fashion. So we all need kind of common model to do all this, whatever way you implement it at the end, as individual manufacturers of equipment and providers of solutions based on DNA data storage. So the work with the Swordfish Twig is an excellent exercise and segue into considering everything the DNA data storage community has to take into account in order to provide a very interoperable environment and set of product solutions, that can walk into the data center and be integrated in the greater picture of data storage, for data centers. So I'm really excited that we have this opportunity. It's I would say it's kind of heavy lifting work in a certain way, because we are discovering a lot of new topics, like I mentioned, about the new types of equipment that needs to be included in the management equation here. And the more we discover what we need to do, the more we realize that there are some elements of the management environment that have not yet been taken into account. Like, and some equipment might require some additional chilling equipment. Others, some environmental, focus, to be, included in all the parameters that need to be tracked with a standard like Swordfish. So, again, we've made a first stab at creating what's required. The DNA data storage community needs to embrace, those concepts, potentially work on them, evolve them, make them bigger, more detailed. This is what's going to happen in the collaboration work we hope to have, with the Swordfish Tweak, based on the feedback we're going to get. And if it takes, as Richelle just said, the more feedback we get, the quicker we get it, the faster we can move. If we don't have that feedback, then we'll take our time, because this is a new topic. Keep in mind that not everyone in the DNA data storage community has a data center background, so we also need to take our time to bridge, those different background participants, in order to make them working on the real issues, on the real challenges associated with the management of DNA data storage resources. But we are pretty confident that this is a great topic of interest for our community, and therefore there should be a great motivation to proceed with the work that we have ahead of us with Swordfish, to make it a strong standard, and to match, as Richelle rightly said, to match the other efforts that have been made for other technologies as part of the Swordfish framework.
Wait, and in looking at the just sort of the raw primitives of operating, as far as like writing and reading data, that in itself, this is a fantastic use case for making sure that we have a standardized approach. We just simply, they're just different artifacts. Of course, they operate differently, which is probably what I want to jump into a bit, Vincent, in what are different in the artifacts. Everything up to this point has been a variation on a theme, but generally with the same sort of fixed management patterns. It's, block, file, object. We mostly around capabilities. There's additional things around heat and placement, and there's a lot of work around optimizing operational with existing traditional enterprise storage. So with this, you're not only mapping a new set of primitives and a new set of operational primitives, but now you're also, the environmental operations are probably much more important in this than they would be in a sort of traditional magnetic or NVMe type of storage environment.
So yes and no. If you look at what has been done in the DNA data storage community at large, you will find a very diversified technology background and scientific background, by the way, because there are very different ways of taking digital input and put it into DNA. So technically, there are so many different ways of synthesizing DNA that can be applied to DNA data storage. That in itself, it's a bit like if we were having very, very different ways of doing SSDs or HDDs of the past. So, and I'm sure the manufacturers are saying, but there are many different ways of doing it. but the reality is that we are in the process of reviewing what all the different ways of doing DNA data storage, and writing, synthesizing DNA, for example, and sequencing as well, DNA for the reading. And the idea is that there will be a common understanding of what's feasible, what's not feasible. And by the way, that's one of the goals of the DNA Data Storage Alliance, is to publish on a regular basis, all the progress of our community, so that the rest of the the ecosystem that we want to be part of inside the data center, understand our constraints. Now, going back to your question about environmentals, it really depends on how you do this. I would think that the majority of the community would aim at having products, technologies that can exist in the traditional context of a data center without requiring very special set of equipment, and I think it's the same for a lot of developers of new technologies, that you want to bring, obviously, new value add. You want to bring differentiation. You want to be, because of what you build, but at the same time, you need to be integrated in an environment, and you don't want to disturb that environment too much. Otherwise, your adoption is going to be in question. So trying to exist in a traditional data center environment is something that we aim at, delivering, at the end of the day, as a community, and obviously as individual vendors as part of this community. So trying to be different, yes. Trying to not be too different is also yes. It's important. Otherwise, in terms of adoption, it creates a kind of a dilemma for the future adopters. Is it worth it? Am I not taking too risk? What's going to be the challenges if I modify too much my environment just to make some room for those new guys with this new fantastic technology? But hey, they're so different that I have to do things so differently that the benefit is not there. So we got to be careful about that overall. We want to be part of the data center and not just be part of a data center extension, which requires special humidity, special temperature, special cooling, special this, special that. At the end of the day, you create so many requirements that the benefits are going to be in question. So we want to avoid that if possible. And the discussion around manageability and environment, is really also about having the possibility to be seamlessly integrated, and that is what we want to do overall.
So one of the things that we've been doing in these conversations is really taking, here's all of this baseline of existing models, and as the DNA team comes and says, here's this thing, I say, is it like one of these? Is it like, is it like one of these? Is it like one of these? And so we can actually go in and take all of these components that Vincent's talking about and match them up as much as possible, adding extensions where needed or changes where needed, but basically saying, this kind of one of these is going to look a lot like a tape library. So, and somebody else's maybe, look different, but we can separate out the logical versus physical modeling. And then like the cooling and power infrastructures, all of those, the Redfish, DMTF Redfish is working very extensively on enhancing all of those just in general. So most of those, we just it's a drag and drop. It's you want these kinds of metrics over here? You need a cooling thing here? Look, we just drop it right in. And so we have a lot of building blocks to work from here. We just need to make sure we're getting to critical mass of folks understanding, do we have this, these couple of these the underlying models fundamentally correct, and then that we can build on, because we don't need the whole thing now. We need kind of the reporting and initial instrumentations and event notifications and the things that are critical when you first move into a data center, and then we can build off of those as we move forward.
So what Richelle just mentioned is absolutely right. We're not trying to reinvent the wheel when we don't need to, So if we can be model-like another type of resource in the data center, then great. So be in tape library or something else. But when we need to specify something that is very much about DNA data storage, like for example, the resource where you're going to pour the DNA into, when it's going to end, we, as the individual product providers, and we all have different jargon, and we're trying to align that jargon. Something like, for example, are we talking about a DNA container, a series of containers? all this is in discussion at the moment, because we all come as individual parties, with different perspective on how it should be shaped, named, and so on. So we need to align on that. That's the work that is ongoing, and the exercise with Swordfish, pushes us as a community to come to a conclusion and to a consensus. So that's the good thing about this, because otherwise we could delay those discussions forever. But in a way, it gives us the opportunity to talk about those very important things, moving forward. And yes, in the DNA data storage space, we tend to talk a lot about the physical resources, but not so much about the logical resources. And that's also a great exercise for our community to get into, because manageability is also about the logical path of things, and that we need to. And the other thing is that, unlike other media, the DNA data storage resources are not directly addressable as a storage entity.
Mm-hmm.
So it's not like you have your disk drive and you cannot mount your disk drive, made on DNA.
There's no fat table for DNA.
Fat table maybe, but there isn't the equivalent of an LTFS, for example.
Right.
In order to mount your tape cartridge and see it online, but you don't do those things yet with DNA data storage. Maybe one day we'll get there, but this is not the case. So we have some constraints as to how the resources in play can be addressed, managed, mounted, utilized, decommissioned, recycled, etc., etc. So we have to map the overall life cycle and associated processes for managing those resources, in a way that is, one, compatible with the way we do DNA data storage, and two, in a way that can be understood by the upper software layers that are going to be tapping into, our resource management systems, based on the API that a source standard can provide. So, this is really a very interesting exercise, as far as I'm concerned, for our community, because I can see it opening so many doors with so many questions that we need to answer in order to make progress, in order to have the opportunity to become properly integrated in the data centers and all the various layers of management that are required to run a data center, and or specific jobs to manage data, to manage storage resources, and so on. So that's very important that we get there.
Luckily, I mean, it's a niche style of implementation, of course, given that this is not a typical mid-market type of storage play. This is going to be used in very specific use cases. And yes, I'll say there's a lot of enterprise storage admins that are glad that they don't have to learn what an illegal nucleotide pool is just yet. But how do we now sort of map those sort of storage artifacts as we know them today, into how we manage, and as we learn, as we build out this new standard of storage deployment?
Well, I think that's where the logical representation really comes to play, because we're using the exact same high-level constructs and saying, okay, how does the DNA has these things, let's plug these in. So you have capacity sources. One of the things we have in Swordfish, as a kind of a richer model than base Redfish has, is we have capacity sources. You can create volumes, file systems, object stores on top of any form of capacity source. It can be memory, it can be hard drive, it can be tape, it can be DNA. And so we're basically taking those exact same models and saying, okay, I have a storage pool, and my pool is made up of these kinds of things. And from that, I've got the attributes here that tell me what I can create. In the same environment, you could have a giant pool of NVMe devices, so you can go be creating namespaces and exporting block files and even file systems on top of that, and in the same place have your DNA. You're using the same types of objects, you're using the same patterns for a completely different technology. Like I have a pool of these, and I want to create a set of objects, and I want to make them accessible over here, is exactly the same series of operations at a high level that you're doing on traditional storage.
So in that one, for people that are developing, how much of the core is there today, for being able to do, understanding what a simple post operation is. Today, we know that element has been defined. They have a certain set of attributes. What work has already been done, and how far along are we in mapping those things to be able to be in product and seeing it work live?
So we basically took one example, and so both the common terminology that the DNA Data Storage Alliance is working on, and then we took one example, and we'd love to see more so that we can see how well we've extrapolated this, and said, okay, this is going to be an object store using storage pools, using capacity sources of type DNA containers or subcontainers, or both. And so that was kind of our starting point. So we said, what would the physical piece is going to be relatively unique per vendor, but it's all common components. So we needed to add a couple of things in there, a couple of new kinds of physical entities. Think of anything that's a FRU needed to be added. But they're just added into our standard stack. The same way you have a chassis with an SSD inside it. An SSD can be modeled as a chassis if you wanted to, or it's just a FRU. So we've done the same thing and proposed some new models for that. What we've done really is in the working draft that's on the website, there's a giant diagram that kind of shows all the different components and how they would cross connect. And we've also published mockups on swordfishmockups.com, so you can kind of go in and see, what this relatively simple configuration would look like and how everything's cross-linked between logical and physical. So the physical ones, you automatically get, anything that was already there, you automatically get all of the event reporting and notification capabilities that are there. And as we're adding some of these new components in, we'll have to say what new specific events do we need to have for these? But there's not really a lot of the rest to do, right? The metrics that are there, like I've already said, the cool power and cooling, all of that stuff's already in place. So it's really just, what are the absolute unique attributes?
And with that, Vincent, what do we have to prepare folks for as far as introducing, wet lab into traditional rack environments? What are the footprints? How much of it's going to be, rack scale versus, what are the current deployments that you're seeing, and where do you see this heading towards?
So let me start by saying that at the moment, no vendor has announced a product that is capable to be deployed as a rack mount unit, for example, or things like that. So there's a lot at play here. The technology we're talking about comes from a biotech background. So there are new elements that need to be taken into account, like the biology that comes with the technology, the chemicals that potentially need to be leveraged and used, to produce some of the DNA. That might be leveraged as consumables, for example. So this very different way of thinking how to make it possible. So I think it's going to take quite a few years up until we see DNA data storage in the format that we used to in a data center, and we shouldn't be surprised about that, because again, remember that in the past we used to have heavy iron in the data center. They used to take, a lot of square footage of the data center, and we were happy about it because they were delivering something very much of value that nobody else could do. Same thing is going to happen with DNA. We're going to start potentially with bizarre shape equipment, Think when I said bizarre, not seen before in the data center. That's the way you have to look at this. And as we move along, we're going to see the industry moving forward and working on what makes sense to gradually integrate as being part of a more traditional approach for deploying, data storage equipment in a data center. So it's going to take some time to get there. I'm confident that it's going to happen. Trying to give you a safe timeline when it's going to happen is a bit of a crystal ball reading at this stage. But let me start by saying that everyone in this industry is motivated to make it happen, one way or another. And we see the benefit because at the end of the day, you were talking early on about use cases. Why are we doing this? It's because we see the need to better preserve data longer term. That's one of the main motivation. And we know that there are challenges with existing media, either economically or physically. Some of the technology today is not meant to last 100 years, 200 years, DNA can, and we see already some segmentation in the, let's say, data archiving, data preservation space. It's been segmented also because there are new ways of leveraging those data pools, especially now that we have AI, taking data from all sorts of different locations to make it work and to produce new results that we couldn't do before without AI. So suddenly, archives are becoming more active, and the traditional archive media are becoming more active as well. So we see a lot of, for example, of archives based on magnetic tape, being sucked in all sorts of AI related, data traffic, where they were not considered as a potential repository for such kind of data pools before. But there's still a need for long-term preservation, for making sure data is safe for very long term, and therefore there will be room for other media, and DNA is certainly one of them. And one of the reasons the Alliance also came to SNIA is also to be connected with other discussions related to long-term data preservation. What does it take to provide the framework, in order to manage all the media related to long-term data preservation in a way that it can be also standardized? So everything we talk about, all the focus and dedication on standards for the manageability with Swordfish is a good example as to what will need to be done as well related to data preservation, because we will also need to leverage other standards in order to provide that continuity in the management and make sure that in 100 years, if you take a DNA data storage device, you will be able to read it and you will be able to access the data on it. This is not a simple task, So beyond manageability, there are also other facets of our technology that also need to be standardized. And the Alliance has already released a few papers about this. This is a starting point. There will be more to come. But this is definitely for us a way of embracing a world of standards that need to be applied to our technology world, and in order to make progress. So there is quite a lot of milestones ahead of us, in order to make it happen. But this is why this is so exciting. There's a lot to do in order to get there. But I'm confident that with our community and with the help of the SNIA ecosystem, we have great resources at our hand to make progress and deliver something of value that can help us to become a more standardized resource in the data center environment.
And I think that brings one of the most important things I find about this community is the fact that any single thing that we're tackling, whether it's manageability, whether it's, building the right APIs, whether it's building, underlying artifacts, physical environments, security, there's many, many, many working groups that ultimately can all participate in this shared outcome. And especially given that it's so fresh and new, there literally is, this is untouched powder, for new areas of exploration. So it feels to me like this is exactly the kind of community we need in order to drive this forward, because if we believe it's just a performance and an optimization problem, and you don't bring in the security teams, or you don't bring in the power and operational management and environment teams, this is where we have risk that when people go along, it may feel like they're going faster, but they're going to run into a wall faster. And this shared delivery and the shared outcomes and the shared goals, it feels like this is the only, or say the most effective way to bring people together that have this broad view into all elements of what it really means to eventually see this as live, on the ground, wet labs, sitting in storage racks in real environments. So Richelle, this must be a beautiful thing for you, having, built this community. And of course, Vincent, you've been a longtime participant and supporter of SNIA. So thank you both for what you've always done to drive this. Richelle, how is this cross TWG and cross pollination really playing out well because of the way that SNIA has been organized?
I think it's more than just how SNIA is organized. It's also how well we work with our alliance partners. So a big chunk of this is radically simplified by the fact that SNIA, with the storage experts, works on the storage specific models, and Redfish can just kind of provide us a ton of base instrumentation. We don't have to focus on that. And it also gives you seamless management with everything. The other piece we haven't really talked about, but Vincent hinted at a little bit with the AI, is how do we bring all this together with sustainability? So we're looking at what instrumentation needs to be there for, Energy Star, what instrumentation needs to be there for sustainability across all the different medium. And all of that is Swordfish will be working on as well. We do expect to see some new sustainability efforts ramping up here in the next year or two. And it's not going to just be, I used my SSDs here, now I want to move them over here. It's going to have to be a lot broader. And maybe that can also take us into a cycle of how do we abstract away more from, we have an archive here and an archive here and an archive here. Do we want to try and consolidate those down? If they're really being actively used, what's the best place for those to actually live? And are we going to try and do any consolidation of the underlying data lake as we're moving forward? So what we've done is, we have biweekly meetings with Redfish. We've brought in requirements from the green storage twig. We have we've sent the requirements to and incorporated specs back from the security twig. So we have a pretty good history inside SNIA as well as outside SNIA of how we basically, take other people's requirements and synthesize them back down into our specifications. We've worked with the Open Fabrics Alliance, we've worked with NVMe. And so, both inside and outside SNIA, most of the functionality we develop is in partnership with one of those groups.
And this is community done right, and especially at the pace we're moving. I'm excited by what we can do now. Like, we literally in the last 3 months, much of our industry on the software side of the world has been, it feels like it's been upended. Like, in reality, the broader software space is still exactly where it was 3 months ago. But if you watch the news, it would feel like it'll all be gone, replaced by a lobster-based software tool at some point. But it's all possible because of what's been done in these developing of standards and the hard yards. We just think right-click deploy volume. It'll be right-click deploy oligonucleotide. Whatever the artifact is going to be, that we can explore this so much easier now, and it's so exciting. So Vincent, given that you've made the move from the storage side of the world to now living in the bio world and that merger between, what does it feel like to you to sort of change camps a bit, but also to bring your history and understanding of the standards focus to what can be done in that world?
You're right. I started to work with storage, traditional storage matters, back in the mid '90s. Definitely, switching to the biotech side of things. I see certainly some fresh air coming my way, because in a way, the biotech guys involved in DNA data storage, they're asking questions that we should keep asking ourselves, thinking about storage at large. And manageability is part of this. And how fast can I go? How big can I go? How secure I am? In the DNA storage community, we have guys focusing on data retention, biosecurity, random access. One thing I didn't mention, and that's part of the excitement, so this is why I'm talking about a bit of fresh air. When we talk DNA data storage, we talk about storage, but there is also a compute chapter to what we do, because DNA focused, technology can also be leveraged to handle certain computational work, like, for example, to accelerate data search. It's not ready for prime time consumption of this kind of technology, but it's there. It's part of the community, and there are discussions about it. So it's in a way you revisit your classics, from a complete different angle, from a different prism, and at the same time you bring tons of innovation, a great scientific community backing up all these developments, because you have to remember DNA is also leveraged outside storage, applications. So there's tons of ideas coming out outside the data storage community, related to DNA, and it's a great source of inspiration as well. You have to remember that one of the reasons we're thinking about DNA as a medium for data storage, because we still can read very, very old DNA that we can find, underground, when you start digging out, prehistoric, artifacts and so on. So it is something that is very exciting. As I say, so it's a way of revisiting your classics about data storage, and apply them to a brand new environment. And at the same time, there's so much technology innovation coming out of this that I think it's a great opportunity to transform, the way IT has been conceived so far. Behind the DNA data storage community, there's also what you could call a molecular IT community that is working to see how the molecular world, can also help transforming IT at large. DNA data storage is a first step towards this, and obviously we have to be successful at this first. But there is hope that there could be a lot more than just storage, behind the use of DNA.
That's it. It's a beautiful bi-directional sharing, because we will find that we likely learn. We think that we're teaching those crazy biotech kids something. It's like, no. We're going to learn a lot about, like, oh, these actually may map over to things that we can do. So yeah, it's an exciting time as we're currently sending a few folks, Fordham, one being Canadian, proud Canadian here, around a little trip around the moon for the first time in a few years. Allegedly, that's for my friends who are still conspiracy theorists that don't think we got there the first time, but we're definitely there. And this is a time of excitement. Like, this is a time where we can say our ideas of the past are becoming products of the very, very near future. And we can be a part of what's being built. And the reason why it's so important to do it in this way, through a community that has this cross-pollination and shared outcomes and shared goals, is that we do the right things about clean deprecation and making sure that standards aren't just for the first launch, but continuous operations. And so it's exciting to watch these worlds come together. And in a world where, unfortunately, people are mostly celebrated by GitHub stars, you find folks don't always get the star that you get to put out in the world. But you are my two favorite GitHub stars today. I can tell you, thank you for spending time and discussing this. And so, Richelle, for folks that want to find out more, what's the right place to point them towards in the SNIA community site? And we, of course, we'll have some links in the podcast as well that we'll add, so it makes it easy for people to click around.
Yes, if you go to the SNIA.org website, and there's at the top the About Data Focus Areas, the drop downs there, go to the technical work and look for the Open for Public Review page. That will have the modeling DNA data storage through Swordfish, that draft model that I talked about. You can always find links on SNIA.org/swordfish as well.
Fantastic. And Vincent, for folks that want to connect with you and learn more or participate in the effort, where's the best place to find you going forward?
So same starting point. Go to the SNIA top page, the SNIA website top page. Look at the group menu and go down to DNA data storage. That's our landing page. The DNA Data Storage Alliance. You'll find a series of papers that we've published already. And further description of some of our activities. The various work groups that are available. And there is a contact link as well if you want to get in touch with us, if you're not sure, what matters to you in that new technology world. So don't hesitate, get in touch with us. And if you're already a SNIA member, you could also see on the members page all the DNA related groups available. So don't hesitate, contact us through the internal system, and we'll be happy to answer your questions.
All right. Well, you got to be in it to win it. And when it comes to zettabyte scale of stuff that we're going to be doing in our world, there is no doubt that this is the path to get there. And thank you both. And of course, for folks, do check out more of these amazing Experts on Data podcasts. Not just because I'm here, but because I'm surrounded by amazing people. I love this chance to share stories. And if you got ideas, of course, drop a comment in any of the places where you find us. You can find us on your podcast delivery of choice on iTunes and Spotify, as well as, of course, on YouTube. So you can see these beautiful smiling faces every time. So thank you both, Richelle and Vincent, and you all have a good time. And we'll see you. Oh, quick event notification. If you're watching this now, we've got Storage AI is happening very soon. That's going to be happening in Colorado. Make sure you go check out the events page. And the big one, of course, Richelle, SDC is tail end of September. What's the quick preview on why they should be already getting their travel schedule organized for that one?
Oh, well, that's simple. It's the Swordfish 10-year anniversary celebration.
Yeah, this is going to be a really, really cool event. And I have a feeling that this is going to be the fastest growing new community, the oldest and newest community, because we're going to see people really seeing the work that's being done and the amazing folks that they can collaborate with. So there you go. So check out SNIA.org, and we'll see you all on the next show.